upon total
Yeah.
number of outcomes. Okay, this is formula of probability. So
Yes,
now
ma'am.
let us
Yes, ma'am.
know about outcomes. So let us understand by using an example, like outcomes and probability. Example, let us take if a coin is tossed at a time or at once, then outcomes we can get either head or tail. So we have two outcomes. Got it? If we want to
Yes,
find
ma'am. Got it, ma'am.
probability
Yes, ma'am.
to get a head or a tail, then we can find as probability to get
Yes, ma'am.
head. Then we can see here one is favorable because we can get only one time head. So one is favorable outcome. And
Yes,
total
ma'am.
outcomes we have two.
Yes.
So probability is 1/2. You got it?
Got it, ma'am. Got it, ma'am.
Now let us do one example when
Yes, ma'am.
toss a coin twice, or we can take a two coin toss together. Like we will have the same outcomes if we toss two coins together or we toss
Okay.
a coin twice. Okay? I'm
Yes,
telling
ma'am.
you how. So what is the date of your exam?
Date, ma'am, it's around 18th, ma'am. 18th October.
18th.
Yes, ma'am.
Okay, okay.
So we'll be doing the class daily, ma'am.
Yeah,
Yes, ma'am.
we will finish in this week, okay? Not to worry.
Sure, ma'am. Sure,
Daily,
ma'am. Thank you.
and we will finish in this week.
Okay. Yes, ma'am.
If a coin toss twice
Okay.
or
Hmm.
if two coins tossed together at once, if sorry, once, then we have same outcome.
Yes.
How? I'm telling you.
Okay.
Then outcomes, we can get either tail on both. Like if we are
Yes,
taking
ma'am.
two coins together, then we can say we can get tail on both coins. Or if we are taking
Yes,
one
ma'am.
coin and toss twice, so we can say we can get tail in both toss. Okay?
Okay. Okay. Yes, ma'am.
And we can get one tail and one head in
Hmm.
two ways, right? Like tail
Yes,
on
ma'am.
first, head on second. And one time we can get head on first, tail on second. And we
Yes,
can
ma'am.
get head on both. So these are all possible outcomes. Okay.
Yes, ma'am. Yes, ma'am.
So we can find probability. Like I'm telling you one more topic here, random variable.
Okay.
Yes. So in previous example, we can take also, but I'm telling you
Hmm.
here, meaning of random variable.
Yes.
Let X be a random variable which denotes, if they'll ask you find for number of hats, then you will take X denotes number of hats. Okay, if they'll ask you find for tail, but they'll ask
Mm.
you most only for hats. Okay, rarely for tails.
Okay.
Like questions, yeah. So let X be a
Yes, ma'am.
random variable which denotes number of hats.
Yes, ma'am.
Then outcomes. Sorry, outcomes we have done already. Now let us take value of X and outcomes. You'll write
Mm.
here. This term is not mandatory. We are doing for understanding. And after that, you can do directly, okay? And then we'll find probability, like
Yes, ma'am.
probability for number of hats, okay?
Okay, ma'am.
Now let us take value of random variable. So
Yes, ma'am.
X will be 0. Like value of X means random variable will be 0 for no hat, right? When we get tail on both, so obviously we can say no hat. Then number of hat here will be 0.
Yes, ma'am.
For one hat, we have outcomes tail hat tail. And
Mm.
maximum we can get 2 hats. So
Yes.
we have only one out. Total
Mm.
outcomes we have 4. Okay, we
Mm.
have 4.
Yes.
Now let us find
Mm.
probability for random variable. So for X is equal to 0, only one outcomes we have. Okay, only one favorable outcomes. So its
Yes,
probability
ma'am.
will be 1 by 4. Are you getting me? Because number of
Yes,
favorable
ma'am. Getting.
outcome we have 1 and total we have 4.
Okay.
Okay.
4. Yes, ma'am. Yes, ma'am.
For one hat we have 2 favorable outcomes. So let us write 2 in numerator and total 4 we have, or we can write 1 by 2. And
Yes, ma'am.
for 2 hats, we have only one favorable outcome. So its probability will be 1 by 4.
Yes, ma'am. Yes, ma'am.
If we
Yes, ma'am.
write values of X and Px together, then this form is said to be probability distribution like this.
Got it, ma'am.
If they'll ask you find probability distribution if two coins together at once or a coin toss twice, then you can form as its probability is 1 by 4, 1 by 2, and 1 by 4. Which is
Yes, ma'am.
probability distribution, or you can say discrete probability distribution, because we have values. For continuous we have class interval like this, 0 to 1, 1 to 2, 2 to 3. So if you have like this, then we say this is continuous. Otherwise, if we have values 1 2 3 and more, then you can say it's
Okay.
okay. For
Yes, ma'am.
in
Yes, ma'am.
discrete,
Got it, ma'am.
we have values, and continuous we have class interval. Okay,
Yes, ma'am. Got it, ma'am.
we can write here which is probability distribution, or you can say discrete probability distribution.
Yes, ma'am.
Or discrete probability distribution.
Okay.
Got it?
Yes, ma'am. Got it, ma'am.
Uh, Next, we have probability theorems, addition and multiplication rule. Then we will do conditional probability also.
Okay.
Conditional probability Bayes theorem. Give me a
Yes,
minute.
ma'am.
I'm just opening my material.
Sure, ma'am.
Before addition and multiplication rule, I'm telling you conditional probability, okay? Then you will understand well.
Yes, ma'am.
Conditional probability. So what is it? Let us understand. Conditional probability
Yes, ma'am.
is known
Yes,
as
ma'am.
the possibility the possibility of an
Yes,
event
ma'am. Hmm.
or based on the existence
Okay.
of a previous event.
Okay.
Like conditional probability means known as the probability of an event. Like this is current event which is based on a previous event. Okay, like one
Okay.
event is happened already, like B event happened already, and event
Yes,
A
ma'am.
depend on this. Then conditional probability of A depends on
Okay.
is said to be conditional probability. You got it?
Okay. Yes, ma'am. Got it.
Okay. So now let us understand the formula, and then we will do
Yes, ma'am.
questions.
Yes,
Let A and B be two events. Then conditional probability
ma'am. Okay.
to happen, A, which is based on B, which is based on B, and B is already happened.
Yes, ma'am.
So its formula is, it is denoted by as
Okay.
PA oblique B is equal to P. P denotes probability. Okay, probability of
Yes, ma'am.
A oblique B. So here B is already happened, and we are finding
Yes,
for
ma'am.
A. Okay,
Hmm.
so it is
Yes,
equal
ma'am.
to probability of A intersection B over probability of B.
Okay.
Okay, and if
Yes, ma'am.
we take just opposite of that, like A is already happened and we are finding for B, then it will be
Yes, ma'am.
like this, or P B oblique A means we are finding for B when A is already happened.
Yes, ma'am.
Is equal to probability of B intersection A over PA. Got it?
Yes, ma'am.
So we will do a question, and before that, let us understand Bayes theorem. Okay, so we will do let it together.
Yes, ma'am.
Bayes theorem. Is equal to P A of B is equal to P V with A into PA over P V. Like if we have these terms already, then we can find probability of A when B is already
Yes, ma'am.
happened. If they'll give you probability of B when A is already
Hmm.
happened, and probability of A and probability of B. This is
Yes,
basic.
ma'am. Got it.
They'll give you, see,
Okay.
we have here four terms, like one in left side and three we have here. They'll give you any three values out
Yes,
of
ma'am.
them, and you need to find fourth. Okay, if they can
Okay.
give you like these values, and you need to find this one, or they can give you like these three,
Yes, ma'am.
you need to find this. So they can give you any three, and fourth you need to find. This is Bayes theorem.
Yes, ma'am. Yes, ma'am.
Now let us do one example to understand this well.
Yeah. Yes,
I'm
ma'am.
sending you this question, then I'll
Yes, ma'am.
explain you in.
Okay. Thank you.
Read this question and let us see here. Two dice are
Yes.
thrown simultaneously,
Hmm.
and the sum
Yes,
of
ma'am.
numbers obtained is 257. what is the probability that the number 3 has appeared? So first of all, I'm going to tell you all outcomes when 2 dice are thrown. Okay, so let
Yes,
us know this first, and then later we will do this question.
yes,
When, first of all, I'm telling you for 1 die, then I'll tell you for 2 dice, then we will do this question.
okay,
Example. If a dice is thrown, then outcomes we can get 1, can get 2, can get 3,
yes,
4, 5, and so 6, because we have 6 numbers on dice face. That is why we can get any one of them when we throw a
okay,
die. You got it?
okay. Yes, ma'am, got it.
And now let us know when 2 dice are thrown. Then outcomes. These are lengthy but easy. How? I'm telling you.
Yes, ma'am.
When 2 dice are thrown, I'm telling you how we can do it. See, we can get 1 on first, 1 on second. We can get 1 on first, 2 on second. Can get 1 on
Okay,
first, 3 on second. Like we will take 1 in this row, we will take 1 on first die,
okay,
and 1 by 1 we'll
okay.
take all numbers on second dice. Okay?
Yes, ma'am. Yes,
1, 4, 1, 5, and 1, 6. And now let us take 2 on first. Take 1 by 1 all numbers on second. Are you getting me?
yes, ma'am. Till 6, we have to do the same process, right?
Pardon?
Till 6, we have to do the same,
Yes,
right, ma'am?
yes, exactly.
Yeah.
So we will have
Yes,
total
ma'am.
36 outcomes.
Yes, ma'am.
But you don't need to write an exam this, okay? We will
Yes, ma'am.
understand
Sure.
in the given question which I have sent you. You will understand well.
Yes,
Whenever
ma'am.
we
Got it.
need, we can take outcomes accordingly. But remember, we have total 36 outcomes when 2 dice are thrown.
Yes, ma'am.
These are total 6 outcomes. Okay.
Yes, ma'am. Yes, ma'am.
So according to question, we have in question 2 dice are thrown simultaneously, and sum of the
Mm.
numbers obtained is to be 7. What is the probability that number 3 has appeared at least once?
Okay.
So we need to find probability that the number 3 has appeared at least one, right? So we
Yes,
will
yes,
choose this
ma'am.
event as a, and which already happened to be found, like sum to be found 7, we'll take as B. Okay, which is
Yes,
because
ma'am.
for to found 7 already happened, and we need to find for 3. Okay.
Yes, ma'am. Yes, ma'am.
So let us consider let event A indicates the combinations
Yeah.
in which 3 has appeared. At least once.
Yes, ma'am.
And we are taking event B as indicates the combination in which numbers, or we can take combination of the numbers
Yeah.
which sum up to 7. So now let us take outcomes. Like we can form the set.
Yeah.
Set A. See, in which A represent combination in which
Mm.
3 appeared at least once. Okay. So how we can take?
Yes, ma'am.
We can take 1, comma 3, 3, comma, and 2, comma 3, 3, comma 3, 4, comma 3, 5, 3, 6, comma 3, and 3, comma 6, 4, comma 6, sorry, 5, comma 3, or 3, comma 5. Yes, 5, comma 3 we have taken. So 3, comma 5, 3, comma 4, 3, comma 2, and 3, comma 1. You got? We have at least
Yes, ma'am.
3 at once. See,
Mm.
1, comma 3, 2, comma 3, 3, comma 3, 4, comma 3, 5, comma 3, 3, comma 6, comma 3, 3, comma 6, 3, comma 5, 3, comma 4, 3, comma 2, 3, comma 1. Yes.
Mm.
So we have here 11 outcomes.
Yes, ma'am.
And in B, we are taking when we have sum as 7. So we can take 1, comma 6,
Mm.
2, comma 5, 3, comma 4, 4, comma 3, 5, comma 2, 5, comma 2, and 6, comma 1.
Mm.
So let us find total outcomes. We have 36. So we can find
Yes, ma'am.
probability for A because here we have 11 outcomes and total we have 36. So its probability
Yes,
will
ma'am.
be 11 by
Right.
36. And here
Yes,
we
ma'am.
have 6 outcomes. So PV will be 6 by 36.
Okay.
Because favorable outcomes we have 6 here and total we have 36.
Hmm. Okay.
And let us see the intersection portion. A intersection B, let us see how many outcomes are in common. See, 4 comma 3 and 3 comma
Yes.
4 we have in common too, right?
Hmm.
So we have
Yes,
two
ma'am.
outcomes in common, 4 comma 3 and 3 comma 4. So let us find probability for intersection. So we have 2 over 36 we have.
Yes, ma'am.
Got it? So now let us find a
Got it.
conditional
Yes,
probability
ma'am.
for A.
Hmm.
So P A of B is equal to probability of A intersection B over P B.
Yes, ma'am.
Yeah. So put the values equal to 2 by 36 and PB is 6 by 36. We can cancel them and we have 2 by 6 now.
Yes, ma'am.
So finally we have 1 by 3. Got it?
Yes, ma'am.
So in next session we will do, see we have done
Yes, ma'am.
probability, meaning of probability, main formula, conditional probability based theorem. Now we have addition and multiplication rule in
Yes, ma'am.
probability, binomial distribution, Poisson distribution, and normal distribution. Okay,
Okay,
so
ma'am.
we will do them in next session. Is that okay with
We'll
you?
do that tomorrow, ma'am. Tomorrow at the same time, we'll do it, ma'am.
Yes. Okay.
Yes, ma'am. Sure, ma'am. Thank you, ma'am.
Okay.
Thank you.